right, lesson 1, 2, day 2, points, lines, and planes continued. So we have some more terms that are used a lot in geometry, and the first one is a segment. It is part of a line that consisting of two endpoints and all the points between them. So I can put a point here, call this point A, this one B, and instead of a line going forever and ever, a segment starts and stops at the two endpoints. So it's the two endpoints and all the points in between. We can name that segment AB, and we do just like we did with lines, but we put a segment symbol above it. A ray is part of a line with one endpoint that continues in one direction infinitely. So we have one endpoint, and it's part of a line, so it goes one direction forever and ever. You could have a ray that starts here and goes out this direction forever and ever. To name it, we always start with the end point, and we need another point on the line. So I could call this ray X, Y. I cannot call it ray Y, X. I'm going to cross that out. That is incorrect because it did not start with X. The ray name always has to start with the endpoint. This one, if I put an A here and a point B here, even though that ray is going to the left, I still put A first and B second and the ray symbol above it. That way, if I know that it talks about ray XY, I always know what the endpoint is. X is the endpoint, A is the endpoint. Opposite rays are rays that share the same endpoint and extend in opposite directions. So if I have a ray going this way, and got to have a couple of points on there so we can name it, that would be ray AB. And if I want a ray that's opposite of that, then that means that I have to start at point A and I go in the opposite direction. So that would be an opposite ray. But I need a point out here to name that one. So ray AB and ray AC are opposite rays. And together they form a straight line. Key information is there, they always have to share the same endpoint. The intersection in geometry of two objects is all the points they have in common. So a very simple example would be if you have two lines that cross. What do they have in common? Well, it would be this point right here. That would be the point of intersection. Okay, if you want to pause the video and do these examples below and then come back and I will show you some possible answers. Okay, if we refer to this figure, we want to name all the rays with endpoint D. So if we just take a look at the drawing, and I'm going to do in different colors, I have this ray, DB. Okay, another ray. If I start at D and go out this direction, DH. I could start at D and go through point G. There would be ray DG. And the last one would be ray DA. 4 different rays with endpoint D. Now, if I picked out a pair that would be opposite of each other, I need a pair that start with D. They have to have the same endpoint and go opposite directions. So I could say DG and ray DH. That's one possible answer. Or, what's the other possible answer? Ray DA and ray DB. All right, name two line segments. There are numerous answers for this one. I'm going to erase all my rays so I can see my points better. So we've got all these, we've got two lines and we've got these points on it. So a segment is just part of a line that has a beginning and an end. So I could talk about from point A to point D. That is a segment. It's a part of the line. So one answer would be segment AD. You could go from G to D, segment GD. And I might point out on segments, order doesn't matter. If I said segment DB, segment BD is the same segment. Both of those represent going from D to B. I went a little bit too far on that line. So anyway, there's two examples. You could also, here's another one. You could go from G to H. That's a segment that's in that picture. Segment GH. All sorts of options. All right, next page. In geometry, we have things that are called postulates. A postulate is a statement that's accepted as true without proof. And I just like to kind of call those, well, duh statements, okay? It's just like, well, okay, that makes sense. You don't really have to prove anything. So here are some basic postulates in geometry. The first one is, if two points are in a plane, then the line that contains those 2 points lies entirely in that plane. So we have a picture of plane H over here, and in the plane, it's showing some points. I have 3 points shown in the plane, point Y, point X, and point W. So I like to think of it, a plane, you can think of it as a piece of paper with 3 dots drawn on it. Well, if all 3 of those dots are drawn that represents the points, then any line that contains those points is also going to be on that piece of paper. So we have line WX. Every single point on that line is going to be on that piece of paper as well. So the question says, draw another line that lies entirely in the plane through points Y and W, W and Y. So you could draw another line. Oh, that wasn't very good. I didn't go through that. Let me erase that. Try that again. If I go from Y down to W and draw another line, you get the idea. Okay, the next postulate we have. If 2 distinct lines intersect, they intersect in exactly 1 point. So I want to draw 2 lines that intersect. We did that on the previous page. Okay. Their point of intersection, I'll call it point P, is where they intersect. Can you draw 2 lines that don't intersect? Do you remember what those are called? Those would be parallel. Parallel lines don't intersect. All right, the next one, if 2 distinct planes intersect, their intersection is a line. So if we look at this drawing, we have plane R and plane S. And so here, plane S and plane R have an intersection that creates a line containing points A, B, and C. So here we've got points A, B, and C, and that's where they intersect. That line, AB, is the line of intersection. If you think of like a floor and a wall, where they intersect would be the seam down at the bottom. It would be all along there, and so it would be one long line is all of the points of intersection. If a plane and a line intersect, they intersect at one point. So in this drawing, if you think of plane R being a piece of paper, and if you can imagine this line M being a pencil that goes down through the paper. Well, it goes down through, it's not laying in the plane, it goes through it. So it goes through the paper at point B, and then these dotted lines mean you can't really see it, it goes down below that plane. And so the line of M intersects plane R at point B. Point B would be the only thing they have in common. Okay, let's see, go ahead and do these next examples and then come back and I'll share some correct answers with you. Refer to the figure at the right to answer the following questions. Name the intersection of plane QRS and plane RSW. Well, in the last lesson, we learned that we only need 3 letters to name a plane, but here's Q, R, and S. Well, where's the plane that contains those? It would be the bottom of the box. And then RSW, here's R, here's S, here's W. Well, what plane are we talking about if we talk about the plane with those 3 letters? It would be this side of the box. So the intersection of 2 planes is a line, and it's all the points they have in common. So, if I use a highlighter here, this line right along there would be the intersection. That would be what both planes have in common. So the answer to that would be line RS, and put the line symbol above it. You could call it line SR. Remember, order doesn't matter in lines. The only time order matters is if you're talking about a ray. Name a point that's coplanar with points X, T, and Q. Okay, so let's identify where those points are. We've got point X, point T, and point Q. If we make the plane that those 3 points are in, then what's another point? Point U is also in that plane. The last one asks if points X, W, S, and Q are coplanar or non-coplanar. So let's identify those points. We've got X, W, S, and Q. Well, these 3 here are all on the back side of the box. So they are all in that plane. But Q is out here by itself. So it's not in the same plane. It's non-coplanar with those other 3 points. All right, if you have any questions over those notes, feel free to come back in on Zoom and ask me to clarify some things. Otherwise, you can get started on MathXL, and again, Zoom in if you've got any questions.